from the other end, where is the carrot? So if you see, there's somewhere around 700, $800 million of plastic tax getting paid. Some numbers say around $400 million, but 400 to $700 million of plastic tax is getting paid in Europe alone. This number will increase. Also, plastic tax, sorry, there's a carbon tax that is getting paid in Europe somewhere around $6 billion. And every time you burn plastic, you have a consequence that you have to pay carbon tax. Somehow it is linked.
The company in delivering 47 successful projects in plastic pyrolysis and oil purification. His innovative solution has gained global recognition as a driving force in plastic circularity and decarbonizations. So let's welcome Suhas on the stage. Okay, thank you.
Thank you everyone. Thank you Smithers for this opportunity. So we are APChemi. We started in India and now we are moving to Netherlands. We have incorporated APChemi Circular BV in Netherlands. The topic of this particular presentation is the vital role of purifying the pyrolysis oil for enabling chemical recycling. So let's look into this. So a bit about APChemi before we start on the main topic. We are leaders in pyrolysis. We've turned plastic, tire and biomass into value. We've developed more than 47 plants in pyrolysis and pyrolysis oil purification. We've transformed more than 179 million kilograms of plastics over 1.3 million hours of technology performance. We're supported by Shell Petrochemicals. Recently, we've worked with Aalborg University to raise funds to convert plastic and biomass into hydrogen. We're working on up to 240 tons per day pyrolysis projects in Europe as well as Asia. The projects that we have developed till date have created more than 3,000 jobs globally since 2007. Recently, we have developed over 7 proof of concepts in chemical recycling of plastic waste, where the oil quantities have been approved at global polymer producers. Oil has also started flowing from a couple of our projects into manufacturer of circular plastics in India. So we have the technology for both pyrolysis as well as purification of pyrolysis oil. We have 12 patents in pyrolysis as well as purification of pyrolysis oil, out of which these 5 patents are granted. So all of us know this big problem of less than 10% is recycled. As Felix said, mechanical recycling cannot solve all the problems. That's why we have to look into chemical recycling. Rest all goes for landfilling or incineration. Also, a lot of plastic waste is burned. Around 300 million metric tons per annum is burned. So from now to 2030, additional 3.5 billion tons of carbon dioxide would go to environment. So if we don't do chemical recycling, carbon footprint also increases. Additionally, around 400 million metric tons of crude oil and gas is pumped to make new plastic. So if you put the problem of linear economy together, crude oil and gas is used to make polymers, which is used by FMCGs, goes directly to landfills, or it is burned. Even if you convert plastic waste into oil, this oil doesn't have a great quality, and that's why this cannot be used as a feedstock for production of polymers. So oil quality being one of the major concerns is the bottleneck for chemical recycling. Let's try to explore this new field of chemical recycling from lens of oil quality. So feedstock for chemical recycling, of course, can be plastic waste or tire waste. Tire also are polymers. So plastic waste that can go into chemical recycling can be of 2 types. It can be either mechanically recyclable or it can be mechanically non-recyclable. So many times we've seen that mechanically recyclable plastic is directly sent into a fine and goes into a cooker. And then that's the distinction that we have to make. Are we supposed to divert the plastic waste away from mechanical recycling and send it directly to refinery? Even a lot of pyrolysis players are using very high quality mechanically recyclable plastic waste to produce high quality pyrolysis oil. So is that the right way to go? Or should we focus on something that cannot be recycled mechanically, take mechanically non-recyclable plastic waste, push it through pyrolysis, do the necessary purification, and then push it to refineries for chemical recycling. So that's the question that is to be answered by all the practitioners in this field. Um, another um, another look at different qualities of pyrolysis oil and where all they can go. Uh, so, so just to tag Q1 is what you can put into a hydrotreater or hydrocracker. Q2 is cracker, Q3 is FCC, Q4 is coker, and Q5 is raw pyrolysis oil. Now Q5 is of lowest cost and lowest quality, assuming that this Q5 is produced from a mechanically non-recyclable plastic waste. But if you produce pyrolysis oil from mechanically recyclable plastic waste, it would probably go somewhere here in terms of cost and quality. It would go match, say, Q1, Q2, Q3, Q4 in terms of quality and cost in case you try to produce it from very high quality plastics. So Q5 is considering that it is post-consumer plastic waste. Then once you produce oil and then purify it, you can produce different qualities of it. So the coker can take the more amount of impurities, so you can produce quality that can go into coker, or then you can also do bit of a, after purification, you can do bit of hydrotreating, hydrocracking to get control over double bonds and aromatic structures and all, and then it can further go into cracker as well. So this is just trying to map out. Now here we are not going into the nuances of chlorine, bromine, hydrogen, chlorine, bromine, nitrogen, oxygen, metal, heavy metal. That requires a very detailed discussion, but this is an overall map of how pyrolysis oil quality can be mapped with respect to quality and cost. So typical quality issues in pyrolysis oil include chlorine, bromine, oxygen, fluorine, silica, acidic impurities, metal, heavy metal impurities. Here what we are not considering is olefinic content and aromatic content, which can be corrected through hydrotreating and to mild hydrocracking as well. So these are the typical impurities that exist in pyrolysis oil that stop it going into the refinery complexes, because refinery complexes are designed for much lower level of impurities. So the way we at APChemi are solving this problem is we can convert contaminated mixed plastic waste, mechanically non-recyclable plastic waste, directly into purified pyrolysis oil. We call it pure oil. Or we can take impure oil and we produce pure oil out of it. So that's where we remove these impurities. In the purification process, there is around 5 to 15% of product loss, but we are able to get to the purified pyrolysis oil, which is right now going to a coker, and plus it is getting tried in a couple of FCC locations. Somebody is also, samples that we had given they have also generated naphtha and jet fuel out of it after purification of our pyrolysis oil. Yeah. So purification efficiencies in terms of the contaminants are considered. We are able to remove up to 99.7% of chlorine impurities, bromine, halogen impurities, also oxygen, silica, acidic, metal and heavy metal impurities. And this is what enables use of PVC, PET contaminated feedstock into pyrolysis. Now, this purification technology is not, it's not one process, it is combination of 5 to 6 different processes, but it does not include distillation or adsorbents or hydrotreating as such. So we are able to purify more amount of impurities at lower capex, opex, and at a lower carbon footprint. That's the advantage offered here. Compared to the conventional pyrolysis followed by purification using adsorbents as well as catalysts, we are able to get the job done at a lesser carbon footprint, because our technology drastically reduces the use of chemicals for purification of pyrolysis oil. We validated our technology. We've received written letters of intent from BASF Germany, Shell Singapore, Unilever Global, BPCL, PepsiCo, and we look forward to our oil eventually going to all possible stakeholders in the industry. So to take a first step, what we have done is we have set up our own pyrolysis oil purification plant near Mumbai. This right now is producing around 1.2 kilotons per annum, and it will go up to 6 kilotons per annum in another 4 to 6 months. Samples have been approved. Some quantities have already started flowing out of this. Commissioning is in progress, and commercial production will start from July 2024. So the model here is that we collect the impure oil from conventional pyrolysis plants that gets purified at our facility, and it goes to our downstream petrochemical partners for production of circular plastics and sustainable chemicals. One of the important factors of this model that we are looking is these global petrochemical polymer producers can give us price protection for purified pyrolysis oil, and we can pass on that protection of offtake price to the impure oil producers. This way, the producers of impure pyrolysis oil will not be subjected to fluctuations of crude oil price rises up and down, and then more and more pyrolysis plants can come up. So we have set up more than 47 plants till date, and we look forward to over the period of next 5 to 10 years developing maybe 50 or 100 pyrolysis plants that can produce impure oil, gets aggregated, gets purified at a central place, and then we supply to our downstream partners. Let's also look at the value chain segmentation of the entire value chain based on the scale of the operation. So if you see household plastic waste generation is in like kilograms, then you have plastic waste aggregator, then you have municipal corporation material recovery facilities, and then you have pyrolysis oil producer of which capacity can vary anywhere between 1 kiloton per annum to, let us say, a dream capacity of 50 kilotons per annum. Above that will be pyrolysis oil aggregator, and refinery capacity can be anywhere around, say, 10,000 to 60,000 KTA. So these large refinery players would not be able to do entire job themselves. So the whole value chain needs to be built. And in case refinery gives predictable prices to pyrolysis oil purification and pyrolysis players, then that can really ensure that the entire value chain will sustain. But if refinery players leave the pyrolysis plants and oil purification plant at the fluctuations of crude oil prices, then that value chain will not grow, which is one of the bottlenecks. I've seen a lot of projects going on hold just because the price protection is not there, and they're saying that you have to match the price of naphtha, which fluctuates a lot. So this is the so refinery is protected against crude oil price fluctuations. Rest of the value chain is not protected, and that's where some steps need to be taken by entire value chain. Also, this slide is probably one of the reasons why we, after staying in India for more than 15 years now, we are moving our holding company to Netherlands, is because even though 95% of mismanagement happens in Asia and Africa alone, still 95% of investments in advanced and chemical recycling happen in Europe and North America alone. So this also needs to be corrected over the period of time. This might take 5 years, this might take 10 years, but if we have to get handle on plastic waste mismanagement, investments in Asia and Africa also need to come up. So also the entire cross value chain collaboration between various parties is essential, whether it is pyrolysis player that purifies the oil, petrochemical companies, polymer producers, packaging companies, FMCG consumers, and plastic waste segregators. Platforms like this help everybody come together and exchange ideas. But yes, the policy also and laws should also make, but sometimes you to find a solution. So let's look at some of the difficult questions that may be asked to various stakeholders in this value chain. So a difficult question to a pyrolysis oil producer would be, can you produce pyrolysis oil quantity that can be used in refinery without much of upgrading? The straight answer is no, you have to upgrade it, and another challenge, the key challenge of pyrolysis oil producer is sourcing consistent feedstock from unorganized markets. Access to de-risking capital is another big challenge that these pyrolysis producers have. EP, extended producer responsibility revenue, is not enough to fill the viability gap funding due to crude oil price fluctuations. So these are some of the challenges that pyrolysis oil producers across the world have. Let's look at the position of, if somebody wants to purify the pyrolysis oil, one of the questions can be, can you compete with crude oil based feedstock in quantity and cost? The answer is no, that crude oil is really cheap compared to producing purified pyrolysis oil. And the challenge is protection against market volatility due to crude oil price fluctuations. So this would be the challenge for crude oil, pyrolysis oil producer purification project. Then plastic circularity. So if we look at plastic circularity focused funds, difficult question would be, how do you ensure scalability and economic viability of advanced recycling technology given the high initial capex as well as operational cost? So this is what makes a lot of investors nervous compared to mechanical recycling. Here the investments tend to be higher, and also there are a bunch of circularity funds that are more focused on greenwashing rather than investing real money. So they have higher amount than actual into the market. So these are the difficult question, and of course the key challenge is high initial capital requirement. And another challenge is that since the earlier presentation saw that most of the infrastructure for chemical recycling is missing. So 80% of infrastructure or 90% of infrastructure for chemical recycling is yet to be built. So there is a huge amount of funds that are required for building such a huge infrastructure. Circular polymer producer, one of the questions would be how to source the quality and volumes of purified pyrolysis oil to meet the recycled content targets. So sourcing that much of a purified pyrolysis oil is not available in the market. Of course, key challenges, health, safety, and environmental challenges of poorly designed plants. FMCG, what percentage content? What is the difficult question would be, what is the recycled content in your packaging? And I mean, what is the chemical recycling viability gap funding for per packet of chips? This is where this is one of the most difficult questions for them to answer. A lot of FMCGs say that I cannot move to chemical recycling or advanced recycling because it is not commercially viable. My production cost would go up. But if you see 1 kilogram of plastic, you can manufacture 500 packets of chips from it, minimum 500. So if you divide the cost by 500, even if 1 kilogram of plastic becomes double, divided by 500, the cost that would go in funding the viability gap of chemical recycling is very less. So this difficult question needs to be answered by FMCG for themselves. What is the viability gap per pouch that I supply to the consumer? Of course, key challenge is sourcing the circular plastics while protecting shareholders' profitability expectations. Another thing is that much of circular food grade plastic is not available. Consumers, of course, the difficult question is, are you segregating the plastic waste at your end? And the key challenge would be, there's no mechanism for consumers to pay for the viability gap for chemical recycling. So for example, if somebody is an educated consumer and they are buying couple of packets of chips, and then they know that this plastic is not going to get recycled, or there's going to be a viability gap. That's why a lot of plastic waste goes for incineration or landfilling. If they can pay, say, $5 $2 cents, or $1 every month, or $5 every month to a QR code, and that fund goes into filling up the viability gap, that kind of option is not available. Compared to that, when you refuel, when you fill up gas in Netherlands, by the time you leave the fuel station, you can pay for carbon offset, and you don't have guilt of producing the emission. So that kind of option, if consumers can pay at fuel stations for a carbon offset, why they cannot pay looking at the packaging for the viability gap for chemical recycling. So thank you so much for this opportunity, and I look forward to engaging with all of you to discuss on this difficult challenge and how we can work together. Thank you. Thank you.
Suhas, stay on the stage. Maybe just give some time. We are ahead of the schedule. Okay. Firstly, overall, my takeaway is seems like you know, a lot of 95% of the waste is sitting in the Asia Pacific or this region, and the rest of the, but a lot
mismanaged.
of mismanaged, right? And a lot of opportunities from the leading area like Europe, right? So I will engage more discussion here. I maybe give some opportunity for the audience to ask some questions that Suhas could answer in person. So anyone have the questions you want to ask? Yeah.
Thank you, Suhas. This is Tarong from BASF. Just a question on the mismanaged waste. You mentioned the majority of the mismanaged waste is in Asia, while investments is in Europe and US. But considering, I mean, yourself, APChemi also moved to Europe in this case, like, how do you think we can be able to access the mismanaged waste in Asia, considering there's no infrastructure here? Like, what would be the key lever in accessing that?
Yeah, so if you see some countries in Africa, nobody even comes to pick up your waste from household waste from home. So at least, you know, countries like India, there's somebody who comes to pick up your garbage every day. So that it starts with if collection is there or not. So some of the African countries, or even some places in Asia, your plastic waste is not even picked up, or garbage is not picked up. Once it is picked up, then it also depends on the money that government is spending in material recovery facilities. So if you see contracts of material recovery facility across, say, Europe or USA, the material recovery facility contractor gets paid anywhere between $40 to 120 euros per metric ton of garbage that comes into the material recovery facility. Now, if you compare that to India, the material recovery facilities in India, the contractors get paid somewhere around $4 to 7, maximum $8 per ton of garbage coming in. So there's they get paid around, say, 10 times to 30 times lesser compared to European American counterparts. So they are not able to install sophisticated facilities to segregate the plastic waste. So these are a couple of key challenges where there is going to be a gap. But again, if you see from the other end, where is the carrot? So if you see, there's somewhere around $700–800 million of plastic tax getting paid. Some numbers say around $400 million, but $400 to $700 million of plastic tax is getting paid in Europe alone. This number will increase. Also, plastic tax, sorry, there's a carbon tax that is getting paid in Europe somewhere around $6 billion. And every time you burn plastic, you have a consequence that you have to pay carbon tax. Somehow it is linked. So such a heavy carbon tax and plastic tax infrastructure that the legislations that exist in Europe, though it will take long time to come, those legislations as well in this part of the region. One of the vision that we have as a group is that we would move the holding company to Netherlands, but still whenever we get a chance, figure out a project in Asia, because we can deploy the projects very cost effectively in Asia. But it's not only about us, it's what the whole world wants to do by having proper amount of money going into collection and segregation at city council level, and also legislations like plastic tax and carbon tax that would help.
Any more question? We will welcome, for this opportunity. Okay, no more question. So yeah, Suhas, maybe I.
Yes, I'm Yuen Mai from Dow Chemicals. So my question is rather generic, but I still would like to hear your answer. So if the question is, what are the top challenges, if you can name it from 1 to 3, that make advanced recycling much more growing at a slower rate than mechanical recycling. So what are they?
So if I understand your question correctly, what are the 3 challenges for
Yes.
helping
That's
advanced recycling grow faster
Yeah, no,
compared to the mechanical recycling?
correct, yeah.
So mechanical recycling is not a greenfield technology. It is a proven technology. It's a proven industry. There's no risk at all. So raising funds for mechanical recycling is far more straightforward than chemical recycling. Chemical recycling is not commercially viable in a lot of places, and that is where first you have to develop the commercial viability by doing some kind of de-risking. So in case of mechanical recycling, you just need fund to deploy an asset. In case of chemical recycling, you need funding in 2 stages. In first stage, you need to do the de-risking, which would involve collecting the plastic waste from 10 different sources that will be supplying the plastic waste to chemical recycling plant, doing the pilots, doing pyrolysis, oil purification, supplying the samples to the downstream player. Also, the downstream player also requires very different qualities of pyrolysis oil depending on where it is going to go into their asset. And then having this entire de-risking done, which can be a job of around 3 to 6 months or so, which is never required in case of mechanical recycling. And one of the core problems why chemical recycling, I mean, this is my personal opinion, why it is not growing is because there is no availability of de-risking finance. Even if like 8 to 10% of capex is made available as de-risking finance, everybody just wants to fund a project.